All right, so we're in section, right now we're talking about section 1.4, and we're going to talk about how we measure angles. But before we talk about how we measure them, we need to know what they are, what they're made of. So we're going to add to our vocabulary. So I passed out a new vocabulary sheet. I'm going to add something just to one of the squares. So in the middle, our term, the thing that we're talking about, is angle. And we want to know all about angles. Definition, the technical definition, pretty easy. Two rays with a common endpoint. So we have two rays that come from the same endpoint. We know about rays. Rays start at a point, go off in one direction. We just have two of them with a common endpoint. So let's draw our picture. Down in the lower right, we can draw a picture of our angle. Grab this. So if you draw your picture, there would be my two rays, and there would be my common endpoint. So there's an angle. And I'm going to label a few points. I'm going to put a point here on this ray, points there at the common endpoint, and point there on that ray. So there's our angle. We call the rays the sides of the angle. So this would go in the facts and characteristics. So the rays are sides. So that's a side. And that's a side. And we call the endpoint the vertex. So this would be another factor characteristic. The endpoint is a vertex. So this is my vertex. Yes. Yeah. So this can go on your definition sheet. So the angle would be our term. Two rays with a common endpoint is your technical definition, and then this would be your picture, and this would go in your facts and characteristics. A couple of other important things about an angle. We call the part between the rays the interior. I'm going to write that in red. So the part between the rays is the interior of the angle. All this stuff out here is the exterior. So just like we would think, the interior is between the rays, the exterior is outside. So we're good with what an angle is. The other thing we need to know is how we name angles. So we were specific about how we name lines with the 2 points and the arrow over the top, the segments, 2 points with the bar over the top. We need to know how we name angles. So this could go in your facts and characteristics. I'm going to say naming. Spell it naming with an E? I don't think so. So to name an angle, we can name them 3 ways. We can name them with 3 points where the middle point is the vertex, and the other 2 points are points on the rays. So we're going to use an angle symbol, and we would call this angle ABC. The vertex, when we name it this way, always has to go in the middle. Vertex is always in the middle. We could call this angle, we use the angle symbol. We can call it angle B, just only use the vertex. Now we can only use this second way with the vertex if there are no other angles at the same vertex. Because if I had another angle drawn here and I just said angle B, I wouldn't know which one I was talking about. So this works only if there are no other angles drawn at that vertex. And sometimes you'll see a number inside here. And this isn't talking about how big the angle is, this is just a number to label the angle. I could call this angle 2. And we never mix these ways up. So I wouldn't call this angle A2C. We're not going to, or C2A. We never mix the two up. We either use letters or we use one number if the number's inside. And we can't call this angle ACB. Vertex always goes in the middle. Vertex is always in the middle. So examples you can come up with all kinds of things that could be examples. We could think of the top of our door when it's partway open makes an angle. My notebook here, when I open it partway, makes an angle. So those would be examples. Non-examples, basically anything that's not an angle. The tabletop is not an angle. The edge of this board is not an angle. The tip of my pencil is not an angle. So those would be non-examples. Something curved wouldn't be an angle. Something that's not made of 2 rays, not an angle. So those would be examples and non-examples. And you can think of those on your own as well. So are we good with this? Our definition, so this is the only definition we're adding to our sheet. The rest is just going to be all information about angles. We're going to learn how we work a little bit with angles. So let's practice a little bit with what we just talked about. So let me draw some angles here. So there are my angles. I'll label some points here. A, D, those are all at the same vertex. B, point C, and I'll call this is a 1. And a 2. I always like to do this. This is when I have an angle here. Watch what happens when I erase this. Or array. Whoops, it didn't make a little arrow there. Maybe it's too small. So it turns it into little arrows. All right. So we want to find other names. Let me redraw this. I don't want to do this. Oops, darn it. Oh, there we go. Other names for angle 1. What's another way we could name angle 1? And this is a 1. Angle, I'll put the answers that we come up with in red. Angle A, D, B. All right, could we call this one angle D? We can't call it angle D because we wouldn't know, are we talking about this angle? Are we talking about that angle? Are we talking about the whole big angle? So we can't name it angle D because there are more than one angle that has that as a vertex. Is there another way we can name it? Angle B, D, A. Just go in the other direction. BBA. How many angles are here? There's this. Not just names, just how many angles do we have? There's this one. So let me highlight. So we have this one. So there's one angle. I have this one, right? Are there any more?
Yeah.
ADC, very nice. Angle ADC, this big one. So we actually have 3 angles there. That's why we can't use just angle D for our to name our angle, because we have 3 of them there. So all of these would work. And we wouldn't want to say angle A1B. We want to use all letters or just the number. Okay, we good with that one. Not too hard. Measuring. Do we know what the name of the tool that we use to measure an angle is? Protractor. Protractor is basically a curved ruler. We measure an angle just like we measure a segment. Our ruler is curved. So let me demonstrate here. I'll draw up an angle and we'll measure it. And I have a fancy protractor. There we go. So what you want to do with your protractor? You set a lot of them have an arrow. There'll be an arrow or a hole or some kind of thing, a cross on the edge of one angle. And then I'm going to put it so that side goes along one of the rays. And then if my angle is smaller than 90 degrees, I read it on the smaller scale. So what would be the measure of this angle, looking at judging by what it looks like here?
65.
About 65, maybe 66. So depending on how accurate and how I might have not placed it here really carefully, might not have put it right on the point really carefully. 65, 66, that's pretty good. So what we say is measure, and we'll call this point A, measure of angle A, M means measure, equals 66 degrees. And we say measure of angle A. So whenever we see that M, that means measure. And if our angle is bigger than 90 degrees, so let me move my protractor and we'll draw another angle. So we'll go back this way, like so. Take my protractor down here, set the point there, lay it right on there. And this time I'm going to read on the bigger number scale, because it's bigger than 90. So what would we say the measure of this one is? About 110. We'll call this one angle B. Measure of angle B equals 110 degrees. So we're at 90, 100, 110 here. Okay, got it? Now let me draw one facing the other direction. We'll move this. So we're going to draw the angle opening this way. We'll call this angle C. So if we have our angle facing this way, we do it the same way. And I'm going to put the line right down there. And whoops. Stay right there. And it's smaller than 90 degrees, so we use the smaller numbers. So what would this one be? about 70 degrees, maybe 71. Looks like it could be. So we would say the measure of angle C is about 71 degrees. So just because we're on this side doesn't mean we use the big numbers. If it's smaller than 90 degrees, we use the smaller numbers. If it's bigger than 90 degrees, we use the bigger numbers. So protractor is like a curved ruler. We use it the same way. So let me, so what we're going to do now, we have an idea of how to measure angles. Are we good with, we'll do some practice. I think this measuring angle is pretty easy. I think Ms. Boss and I talked about coming up with a worksheet for the weekend that's, it would be extra credit where you can measure angles and maybe get a little extra credit. What we want to talk about now is special kinds of angles. They happen, we give certain names to certain kinds of angles that are special. So let me get rid of, don't need that anymore. Special angles. And most of them we already know. So when we're talking about a right angle, what kind of angle are we talking about? What's the measure of a right angle? 90 degrees. Right angle, 90 degrees. The way we draw a 90 degree angle just looks like a corner. So we go like so, and like so, and we have a special symbol for right angles. We draw a little square. So that's 90 degrees. How about a straight angle? What would a straight angle be? 180 degrees. We talked about a straight angle. Straight angle is just a straight line. Straight angle is 180 degrees. So for that, we're just talking about a straight line. So we'd have an angle going, a ray going that way, and a ray going that way, and there's our vertex. Straight angle is the same thing as a line, except we have this point that we're saying is our vertex. How about an acute angle? Acute angle is less than 90. And just to be a little more accurate, we'd say between 0 and 90. And if it helps you remember, you can think of a cute little angle. It's a little angle. And then the other special one is obtuse. From 90 to 180. So an obtuse angle is between 90 degrees and 180 degrees. So just a bigger angle, bigger than 90 degrees. So there's my obtuse angle. Put my vertex there to fill in that gap. So those are our special kinds of angles. Right, straight, acute, and obtuse. And we can sometimes we'll ask you to decide what kind of angle it is just by looking at it. Sometimes we'll measure. Usually in geometry, unless it tells you that an angle is a right angle, you can't say, oh, it's a right angle because it looks like that. Oh, it's acute because it looks acute. Unless the problem tells you that, you can't necessarily assume that that's true. So there are some questions where we'll say, what does it look like? And we're asking for these kinds of things. Otherwise, you would have to know somehow. You'd have to have some kind of evidence that you have a right angle, or a straight angle, or an acute angle. So just because I draw an angle that looks like this, you can't say, oh, that's a 90 degree angle. It could be 89.5 degrees. It could be 90.7 degrees. It's not necessarily a right angle, unless you say it. All right. Questions about special angles? Okay. So now we want to know how we compare angles. Well, thinking back to what we did yesterday, how did we compare segments? How do we decide if they were the same, if they were the same size and shape? We measured them. And we measure angles by using a protractor. So we can talk about their measure, or we can talk about comparing the angles themselves. You remember the word that we used when we, rather than their lengths, we were comparing the segments? Started with a C. Congruent. So we can measure our angles, or we can talk about angles being congruent. So we use them the same way. So comparing, we use the word congruent. Congruent angles have the same measure. And we use the same symbol. We say, if we're talking about their measure of angle A equals the measure of angle B. Or we just say angle A is congruent to angle B. They have the same measure, they're congruent, they have the same measure. When we're talking about measure, we're talking about the degrees. And we show on figures that angles are congruent with either arcs or tick marks. And what I mean by that is I'm just going to draw several different pictures here. If they have the same number of arcs, that shows that they're congruent. So there are the angles with one arc. I can draw two arcs to show that these are the same. I could draw three arcs. So one arc, two arcs, three arcs. That shows that they're congruent. I can also use tick marks, like I used with the segments. So let me draw a couple of angles with tick marks. So I can do this. And I can use as many tick marks as I want. So for all of these, we're saying angle A is congruent to angle B. I mean they have the same size and shape. If we measure them, they should have the same degree measure. They have the same number of degrees. So we can use one arc, two arcs, three arcs, four arcs, five arcs. Usually it gets more confusing after three. You can use one arc, one tick, two ticks, three ticks, four ticks. Usually you won't see more than two or three. So that's how we compare angles. We say they're the same measure, or we say they're congruent. And this is what it looks like in pictures. So we're good there. So a big part of what we're doing in the first part of chapter 1 is we're getting all of our tools. We're kind of building some tools. How do we talk about these things? What's our vocabulary? What do we mean by congruent? How do we show it in pictures? So there's a lot. Unfortunately, it's a lot of words. We're doing a lot of talking. This is what this means. This is what that means. This is how we do this. How we do that. Well, what we start doing then in chapter 2 and later is we start doing stuff with all of our vocabulary. We start putting things together. So chapter 1 is kind of a lot of building of basics. So I know it's kind of wordy, but it gets more. We do more as we go on. All right. So now we're on to our first postulate with angles. The angle addition postulate. And what did we decide? Or what did we say a postulate was? Can you help us out, Lydia? Postulate? Something that we accept as true without proof. So this is our postulate about angles that we're going to accept as true without proof. Do we? What postulate did we talk about yesterday? That really our only postulate yesterday. Do we remember? What were we adding yesterday? What's that? Segments, line segments. So we added segments. So we had a segment addition postulate. Angle addition postulate is really the same thing. It's just about angles instead of segments. So we're going to say that we have angle AOC. And we're going to say point B is in the interior. When this happens, then, and it sounds more complicated in words than it really is, the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. So let's draw a picture of what we're talking about. This makes it sound complicated. It's really not complicated. Oops, let me undo that last one. So here's angle AOC. The postulate says that point B is in the interior. So where am I going to put point B? Inside? Is this the inside? No. This right here, along here on the inside? No. Right here at the tip of the ray? No. In here? Okay. All right. Yes.
The angles have to have arrows on it?
Yes. So right now we're saying that angles are made of rays. So for now we're drawing, we can talk about angles made by segments, but right now we're saying that our angles are made of rays. So we'll draw our angles with rays. All right, so we're going to, there's my point B. I'm going to draw a ray from O through B. There we go. Angle AOB plus angle BOC equals angle AOC. The two small parts add together to make the big part. So the small angles, I'm going to write it this way, add together to make the big angle. That's all the angle addition postulate is telling us. So when I have our angles like this, I can add the smaller parts and it gives me the bigger part. Makes sense, right? Just like I did with segments. We put the pieces together, we get a big piece. We're going to use it exactly the same way as we did with segments. We're going to figure out how angles fit together. So if angle, do a couple of easy examples, or an easy example, and then we'll do a more complicated example. If this whole thing is 100 degrees, and this angle is 25 degrees, how big does this angle have to be? 75, right? The two small pieces have to give me the big piece. So this piece has to be 75. When I add these two together, I have to get the measure of the big angle. That's really all the angle addition postulate is telling us. Now, of course, in math, we like to make things more abstract. So we're going to use variables with our angles. So let's take a look at an example of that. Black, there we go. Oops. So here's my setup. We'll call this A, B, C, and D. A, B, C, and D. And the problem tells us that the measure of angle ABC is 175 degrees. And we know this is 6x minus 5, our favorite letter in math, and this is 4x plus 10. And the problem asks us to find the measure of angle ABD and the measure of angle DBC. All right, so what are we going to do here? Have to find x. That's going to be our goal, is to find x. Once we find x, we can plug it in and solve things. So how are we going to set this up? Well, first off, let me ask you a question. So Abby, where angle ABC? Which angle is angle ABC? The biggest one. We're talking about this big one. So if it helps you, label this. That's 175 degrees. So the biggest angle is 175 degrees. Well, what does this angle addition postulate tell us? That we can do with small angles. Add them together, and it gives us bigger angles. So what's one of the smaller angles? What does the problem tell us it is? Ashley?
5.
What's one of our small angles here? What's the problem tell us it is?
ABD.
ABD. And what is it? What is its measure?
6x.
6x minus 5. And we said we're adding the small angles. What's our other small angle? Casey? Casey's not in here anymore. Jordan, M.
It's ABC and it's 4x.
And we're adding, right? 4x plus 10. And when we add those together, we get the big angle, 175. And I'm going to leave the degrees off. So what do we do next? Sam? Find x. So how do we, from what we've written here, how do we find x? Combine like terms. Very nice. So what do we want to combine here?
6x and 4x.
And we get 10x. What's another? What else are we going to combine?
Negative 5
Plus 5, and that equals 175. All right, Michaela, what's our next step?
Minus 5.
Minus 5, nice. We're almost done. We're almost home free here. 10x equals 175 minus 5 is 170. Next step, Maddie? Divided by 10. Beautiful. We're almost done. X equals 170 divided by 10 is what? 17. We're done. I'm going to write this down as my answer. Now we have to plug it in. Oh, the problem asks us to find the angles, not just to find x. Find x was just our intermediate step. So we can plug x in to up here to find our angles. So the measure of angle ABD equals 6 times 17 minus 5. I'm going to plug that in my calculator and calculate that out. When I calculate that out, I get 97 degrees. The measure of angle DBC is 4 times 17 plus 10. And when I calculate that out, I get 78. How can I check my work? Add them, and I should get 175. So when I add these two together, do I get 175? Yes, check. I'm done. I've answered the question. Everything makes sense. And if the problem gave us a slightly different setup, if it gave us a number here and some kind of variable here, I do the same thing. Add the pieces, the smaller pieces, and it equals the bigger piece. Add the small pieces to get the big piece. Questions on that example? Okay. I'm going to pause here. That's one lesson done. About for our second part. Again, this doesn't happen often, just because we missed days because of the rain. So the second part of today's lesson, we're in section 1.5. We're going to talk about special angle pairs. So now we know how to measure angles, we know how to compare angles, we know about angle addition. We want to talk about some kinds of angles that come up so often that we give them kind of like right angles and acute angles. Angle pairs that come up so often that we give them special names. So the first one is adjacent. So just thinking in everyday terms, when we say two things are adjacent, what do we mean? If I said the math office is adjacent to my classroom. Next to. Adjacent just means next to. Very nice. So that just means these two angles are next to each other. So adjacent angles, there are a couple of things that have to happen. They have a common side.
Wait, is this another term?
This would it doesn't have to go on your sheet. So this is just a special kind of angle. Adjacent angles have a common side, a common vertex, and they don't overlap. So if I drew a couple of pictures of adjacent angles, we've already drawn a couple. Angle 3 and angle 4 are adjacent angles. They're next to each other. They're common side, they share a side, the side here in the middle, and they share a vertex. So those two angles are next to each other. Another example of adjacent angles would be something like this. Angle 1 and angle 2 are adjacent. Their common side here and their common vertex right there. So for adjacent angles, all we mean is they're next to each other. Vertical angles. And I'm going to put a little star next to these. Vertical angles are very important. We use vertical angles for lots and lots and lots of things in geometry. Vertical angles are two angles and they have opposite rays as sides. The way I usually think of them is they they make an X. So if we drew vertical angles, I'm going to draw two opposite rays. There are two opposite rays. Angle 1 and angle 2 are vertical angles. They have opposite rays as sides. Angle 3 and angle 4 are vertical angles. Even though they're not vertical from each other, we can still call them vertical angles. The way I usually think of vertical angles is they're across the X from each other. Angle 1 and 2 are across the X, angle 3 and 4 are across the X. So we have two straight lines, opposite rays that make their sides, and they're across from each other on the X. We'll use vertical angles for lots of things in geometry. So those are our first two special angle pairs, adjacent and vertical. On this picture, which angle is adjacent to angle 1? Angle 4 and angle 3. So those would be adjacent. So we have vertical angles here. We have adjacent angles here. So several different things happening. All right, are we good on adjacent angles and vertical angles? Okay. Complementary angles. Complementary doesn't mean they say nice things about each other. Two angles that add to 90 degrees. Complementary angles are also very important. So, whoops, let me get a ray there instead of a line. So here's my 90 degree angle, and I'm just going to split that. So here's my 90 degree angle. That little square means 90 degrees. Angle 1 and angle 2 are complementary. If we added them together, they would add up to 90 degrees. Let me draw two other complementary angles. They don't necessarily have to be situated next to each other. That one's 23 degrees. And that one's 67 degrees. 23 plus 67 is 90. So those two angles are complementary. We add them together, we get 90 degrees. When two angles are complementary, we say they are complements of each other. Two angles are complementary, they are complements of each other. One is the complement of the other. Okay, we good there? I know we're covering a lot of ground, a lot of words. Like I said, that's kind of what happens in chapter 1 of geometry. Learning a lot, almost like learning a new language. Supplementary. What would you guess supplementary means? If complementary means they add up to 90, what would you guess supplementary is going to mean? What's another important angle that we talked about? Just 180. Supplementary. Two angles that add to 180. So when we put them together, we get what kind of thing? A straight line. Yes, nice. So two supplementary angles. They're supplementary angles. Angle 3 and angle 4 are supplementary. They add to 180. They don't necessarily have to be next to each other. I could have them situated like this. And if this one was 57 degrees, and this one is 123 degrees, those two angles would be supplementary because when we add them up, we get 180 degrees. We say they're supplements of each other. Complements, 90 degrees. Supplements, 180 degrees. All right, so I want to draw a picture, and I want to ask some questions about this picture. So here's my picture. And I'll put some points on here. There's point L, point P. This point in the middle is point A. Point O, I'm putting a point on each of the rays here, M and N. And this is 74 degrees. And I'm going to move my A. And this is 106 degrees. All right. Are angle PAL and angle LAM adjacent? PAL and LAM. Are those adjacent angles? Yes. They have a common side and they have a common vertex. So that would be a yes. Are angle PAO and angle NAM, are those two angles vertical angles? Does everybody agree? PAO, so let me mark it, let me highlight it. PAO, and I'll do a different color here. MAN. Are those two angles vertical angles? Marie says no. You say no, Lydia? A couple people said yes. What do we think? Are the sides straight angles? Here's a straight angle. Is this a straight angle? No. So the sides of our vertical angles have to be straight. They have to make lines. So because this isn't a line, those two would not be vertical. So those two are not vertical angles. Because this isn't a straight line. The two sides of the angles have to be straight lines for them to be vertical angles. Are angle PAO and OAN supplementary? Supplementary means they add to 180. And when we put them together, we get a straight line. So if I add 74 and 106, that adds up to 180. And PAN is a straight line. So that would be a yes. Those are supplementary. So with vertical angles, be careful. Make sure that the sides of your angles are straight lines. If one side is curved or bent, then they're not vertical angles. All right. A couple of other things. We're almost done. A linear pair is another special pair of angles. A linear pair is two adjacent angles that form a line. So let me draw a linear pair, and I think you guys will be able to pick out what is, whoops, didn't want that, I want that. What is special about a linear pair? That is supposed to be a straight line. So there's a linear pair. Angle 1 and angle 2 make a linear pair. They make a straight line. What do we know about angle 1 and angle 2? They're supplementary. They add up to 180 degrees. Linear pairs are supplementary. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So linear pair is another way of saying that they're supplementary. So they're adjacent angles that form a straight line. All right, let's look at a couple of problems. Yes? The PAO and OAN?
Oh yeah, OAN.
Uh-huh.
I mean, yeah. Would that mean that PAL and LAN were?
So the question is, if we know that these are supplementary, we know this is a straight line. So what Maria's asking is if we add this angle, right, plus that angle, would we get 180 degrees? What do you guys think? Yes. So those two angles would be supplementary. They would form a linear pair also. Very nice observation. Yes? Not exactly, but we would know. That's a good question. Is there a name for three angles that add up to 180? Not really. But we would know that this piece plus this small piece plus that small piece, if we added all three of those, it would have to equal 180. So that is definitely true. If we divided this into a bunch of pieces, if we added all the smaller pieces, they would all have to add up to 180. So good observation. Very nice. So all of those things that we just saw, those are true in this figure. Okay? It's good. Very good. I'm impressed. All right, let's look at a drawing and see what we can figure out here. Do this, and do this, make these lines. And then an angle array here. All right, so we're looking at this figure, and we want to know what we can figure out from this picture about how the angles are related. So just looking at the way this is drawn, what are some of the things that we can say that we know are true for sure about this figure? What was it? Angle 1 and angle 2 are the same, so we can say angle 1 congruent to angle 2. You know they're the same because they're marked the same. What else could we figure out? What do you think?
Angle 5 and angle 3 are...
Angle 5 and angle 3, they are adjacent, and what were we thinking? Are they vertical or the other thing?
I don't know what it's called, but I know what you're saying.
What are they?
It's a straight line.
It's a straight line, so they add up to if we had their degrees, they would add up to 180. Supplementary, very good. Angle 5 and angle 3 are supplementary. That's a good one. Are there other supplementary angles there? 3 and 4 make a straight line. Angle 3 and angle 4. What's another way we could say angle 5 and angle 3 are supplementary, angle 3 and angle 4 are supplementary? They form a linear pair. So angle 3 and 5 and angle 3 and 4 form a linear pair. Anything else we can figure out? What do you think?
Okay, I have a question.
Okay, question?
So, could 4, 1, 2, and all those angles be supplementary, or is it only like 1?
We could say angle 4, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 1 equals 180. We could definitely say that. It can be more than just one. It could be more than a pair. All three of those, if we added all three of those up, those would add up to 180. So we could write that down. The measure. Yes, so I wouldn't say these are supplementary. I wanted to say if we add those up, come on, equals 180 degrees.
So
Okay. We wouldn't say they were supplementary. Okay. Angle 5 and angle 4 and angle 4 are vertical. Because the sides of this one are a straight line, the sides of that one are a straight line, and they're directly across from each other on that X made by those two straight lines. And then we have some adjacent angles there also. So we have some adjacent angles as well. But these are really the big ones, that these are supplementary, the congruent angles, and seeing that those three all would have to add up to 180. So that's the main ones that I wanted to stress. All right. Let me look at an angle bisector, and then we'll be done. So we have some supplementary, vertical, complementary, congruent. So let's look at an angle bisector. Let's remember what bisect means. What did we say bisect means, Ashley? No? Cut in half. Cut in half. So if we're talking about an angle bisector, we're talking about something that cuts an angle in half. So we're going to say a ray. We're going to use our technical language that divides an angle into two congruent angles. And what we mean is it cuts in half. So if we drew a picture here, here's my angle, here's my bisector. Those are congruent. Call this X, A, and Z, and Y. So we say ray AY bisects angle XAZ. We know that angle XAY is congruent to which angle? On this figure. YAZ. And we say that ray AY is the bisector. Ray AY is the bisector. Cuts it in half. So if LM is the angle bisector, what is the measure of the angle in red? Ray LM bisects the big angle. What does this other angle have to be? 42. Divides it into two equal pieces. Bisect means cut in half. So each piece has to be the same. So just like we did with segments, if we had some kind of algebra problem that had to do with the angle bisector, the two pieces would be equal. So if we had x's in here with this equals this. So that's how we would solve that problem. Let me go back here and talk about a linear pair. If the problem gave us some kind of algebra problem that involved these two angles, how would we go about solving that problem? We're talking about two smaller pieces adding up to be a bigger piece. For a linear pair, or for supplementary angles, what is the bigger piece? 180. So this angle plus this angle equals 180. And then you can solve the problem. We're talking about complementary angles. You go back to complementary. This angle plus this angle equals 90. Same problem that we've talked about over and over. It's just what they add up to and how we put them together. Complementary, this angle plus this angle equals 90. Supplementary, or linear pair, this angle plus this angle is 180. Bisectors, this angle equals this angle. So we'll be doing the same kind of problem over and over. This segment plus this segment equals the whole thing. This segment equals this segment. So two types of problems we do with segments. Angles, this angle plus this angle equals something, or this angle equals this angle. And work our problem that way. All right. You guys have been troopers today. That was a long class. So you guys did a great job.